If I were to ask many of you what you thought the biggest danger from climate change was, I imagine some of you would say sea level rise, others would say heat waves, and some might even say ecological collapse. However, I believe that none of these impacts are the worst. In my opinion, tipping points and their consequences are going to be the worst effects of climate change, impacting every person on this planet for millennia to come. Generally, people understand climate change as a problem that will get worse as time passes, maybe affecting them, maybe not. We will experience harsher heat waves, stronger storms, and rising sea levels will displace millions of people and destroy dozens of violent nations. But this isn't actually the case. Tipping elements can cause rapid change to large regions of the world, having impacts far greater than the gradual worsening of the climate we're used to. As a clarification, tipping elements are the climate systems that can tip. Thresholds the amount of change required in a certain parameter, such as average temperature, for the tipping element to tip into a new state. The term tipping point can be used for either. However, I will use tipping point as a general term while specifying exactly what I mean by using tipping element and threshold when necessary. So, tipping points, what are they? The most up-to-date review on them by Mikhail et al. In the Science magazine last year has the following definition. Tipping points occur when change in part of the climate system becomes self-perpetuating beyond a warming threshold as a result of asymmetry in relevant feedbacks, leading to substantial and widespread Earth system impacts. The definition used to require rapid and irreversible change, but these have fallen out of use in recent years due to the fact that certain tipping elements, such as those associated with ice sheets, occur over hundreds to thousands of years, while some tipping points have shown to be reversible, if only over many thousands of years. Their definition of threshold is a forcing control parameter in which a small additional permutation within natural variability of 0.2 degrees Celsius causes a qualitative change significantly larger than the standard deviation of natural variability in the future state of the system. In simpler language, this means the threshold is where a small and normal fluctuation in the climate could cause a massive disproportionate change in the system. The threshold is usually given in degrees of warming, which implies that tipping points are only affected by increasing temperature. However, this isn't the case, and we only focus on temperature due to the difficulty of simulating the Earth's climate. For instance, the Amazon rainforest is a tipping element which is dependent on both temperature and level of deforestation, so we can hit the Amazon rainforest tipping point much earlier than expected if large-scale deforestation continues. The paper identified 16 tipping elements and categorized them as either a global core tipping element or a regional impact tipping element. The main difference between the two is their impacts. Global core tipping elements contribute significantly to the overall normal functioning of the Earth's climate system, while regional either contribute significantly to human welfare or have great value in themselves as unique features of the Earth's system. Of the 16 tipping elements, 9 were identified as core compared to 7 as regional. The 9 core tipping elements are the Greenland ice sheet collapse, the West Antarctic ice sheet collapse, Labrador-Ingles Sea Convention collapse, the East Antarctic subglacial basins collapse, the Amazon rainforest dieback, boreal permafrost collapse, the Atlantic meridional overturning circulation collapse, the Arctic winter sea ice collapse, and the East Antarctic ice sheet collapse. The 7 regional tipping elements are the low-latitude coral reef die-off, the boreal permafrost abrupt thaw, the Barents Sea ice abrupt loss, the loss of mountain glaciers, the greening of the Sahel and the West African monsoon, boreal forest southern dieback, and boreal forests northern expansion. From now on, I'll use the shortened versions of their names because those don't exactly roll off the tongue. Now, there may seem to be some duplicates there. For instance, why are there 3 tipping points associated with the Antarctic ice sheet? However, the distinction is a result of the different behaviors of the 3 sections of the ice sheet, as certain parts will collapse at a much lower temperature threshold than others due to separate tipping dynamics. Due to uncertainty in climate models, they don't have concrete thresholds, but rather have the possibility of tipping over a range of temperatures. The ranges of all the tipping points are shown here, and as you can see, many of the tipping elements have potential thresholds not much higher than the current warming of 1.1 degrees Celsius above pre-industrial levels, with 5 tipping points already possible. At 1.5 degrees Celsius, 10 tipping points are possible, 4 of which are likely. The world is on a trajectory to hit around 2.6 degrees Celsius, with an uncertainty range as high as 3.7. At 2.6 degrees, the list increases to 13 possible, 7 of which are likely. By limiting warming to even 1.5 degrees Celsius, we aren't safe from tipping points. Even now, there is a small but real chance we've hit some tipping points. For instance, there is increasing evidence that the WAIS has destabilized when the threshold has already been crossed. If this is true, then it's very likely that the entire WAIS will melt in the next couple of millennia, adding a few meters to sea level rise. Even with the lowest projected temperatures for the most optimistic IPCC pathways, it's likely that 4 or 5 tipping points will be hit in the next few decades. Well, what are the impacts of these tipping elements? So what if we hit them if they don't have significant impacts? The impacts vary wildly. The GIRS will cause around 7 meters of sea level rise, while the EAIS will raise it by around 50 meters. Ecosystem collapses such as the die-off of coral reefs would massively impact tropical fishing and increase food insecurity for millions of people. The AMOC significantly affects weather patterns throughout the Atlantic and could decrease temperatures in the northern Atlantic by as much as 10 degrees Celsius, significantly changing the climate of Europe to be more like that of Canada. Each tipping element will affect the global average temperature in some way. Some cause an increase while others decrease it. Currently, the estimated increase in warming due to tipping points is significant but not devastating. It looks like we still have control over our climate, but this isn't guaranteed, especially in our rapidly warming world. All of the tipping points have different tipping dynamics, meaning the timescales for their impacts are very different. Some completely tip in a few years, while others take centuries to millennia to fully change state. There is also a level of confidence associated with each tipping element, their respective threshold, timescale, and temperature feedback, ranging from high to low confidence. For some tipping elements, it's possible to cross the threshold for a short time and then decrease the average temperature to below the threshold again without triggering the tipping element. This is mostly only the case for ice sheet tipping points, with potential allowable overshoot times of a few decades. But how long we can stay above their threshold depends on how high we overshoot it. This does mean we have a bit of leeway when it comes to sea level rise, because we are almost certainly going to reach the thresholds of the WAIS and the GRIS, but if we can reduce the temperature back down quick enough with carbon capture, then we may be able to avoid triggering the tipping points. Some climate systems used to be classified as tipping elements, but aren't anymore. This included the El Niño Southern Oscillation, the Indian Summer Monsoon, and the Arctic Summer Sea Ice. Other potential tipping elements which haven't been classified yet but have the potential to be with further research include the Yerima permafrost region, the Congo rainforest, and subtropical stratocumulus cloud breakup, among others. There is also potential for what's called a tipping cascade, which is where one tipping point causes or lowers the threshold for another, causing multiple tipping elements to change state in a short time frame. Interactions between tipping points have most notably been seen between the AMOC and the AMAZ, the GRAS and the LABC, and the LABC and the AMOC. These interactions, as well as the temperature feedbacks from individual tipping elements, have led to research into a global tipping point, where many tipping points trigger each other in rapid succession, causing the Earth to transition into a hothouse climate. Like many of the tipping points, the threshold for such a global tipping cascade has much uncertainty, but it has been estimated to be as low as 2 degrees Celsius. Some climate systems have some but not all the properties of tipping elements. These are generally called threshold-free feedbacks, as although there may be a self-reinforcing feedback, there is no clear threshold. The Arctic summer sea ice is an example. Less summer sea ice reduces the amount of radiation reflected back into space, increasing the temperature and further reducing summer sea ice. This highlights one of the key aspects of tipping elements very well because it shows that the feedback loops have to be triggered at a certain point. It can't be a passive feedback loop that is always running in the background. There has to be a change in the way the system runs for it to be classified as a tipping element. The feedbacks also have to be powerful enough for the change to continue even if warming stopped, which also isn't the case for Arctic summer sea ice. It may seem like those tipping elements, which take hundreds to thousands of years to show their full impacts, are less important than the shorter timescale tipping elements. However, it's important to remember that the people of the future are just like us. They have their own problems we can't fathom. They won't be in a better position to act than we are. Technological breakthroughs won't save them. We already have the power of gods, and magic bullets only work when there is a monster to shoot. The very nature of tipping points means it will be impossible for these people to halt the progression of the tipping points, even if the average temperature had been lowered back down to pre-industrial levels for generations. Which trail of dominoes we decide to push now will have consequences that stretch forward into the history of humanity, further than we could possibly see. There is a huge amount of uncertainty to do with tipping points, but don't mistake uncertainty as guesswork. The thresholds and temperature feedbacks of tipping points could be lower or higher than generally agreed. However, their existence is something we can be sure of, as we can see tipping elements in their alternative states in the paleoclimate record. The impacts of tipping points are far too high to bet against. We need to do everything in our power to try to minimize the number of tipping points we trigger in the next few decades. Tipping points are the long-term impacts of climate change. The effects we are seeing now are terrible and causing massive damage, but if we survive the next couple of centuries and reduce the Earth's temperature back to pre-industrial levels, the climate will return roughly to how it was before. However, once tipping points are triggered, the Earth will be significantly changed so that even with no further warming, the Earth's climate won't be the same for at least many thousands of years. The impacts of each tipping element is as varied as the tipping elements are themselves, and each one deserves a video to do it justice. If you want to see that happen, then please consider subscribing and liking the video. It really mean a lot to me. For those of you who can't tell this is my first video, any feedback in the comments is much appreciated, and thank you for sticking to the end. I'm currently working on another video, and then after that I'll see how these go to decide how to continue from there. Again, thank you for watching all the way through.